spends extensive research in the domains of fuel cells, hydrogen, and intricate mathematical modeling of integrated energy systems. His scholarly pursuits have been anchored in an array of compelling studies, primarily focusing on various critical areas. These encompass the modeling of direct internally forming solid exude fuel cells, pioneering advancements in material development and mathematical modeling for direct methanol fuel cells, and trailblazing development of high-temperature PEM fuel cells. Professor Cholpan's contributions extend to stimulation and optimization of fuel cell vehicle powertrains, catalytic dehydrogenation of solid hydrogen storage materials, analysis of organic Rankine cycle-based systems, and the exploration of biofuel turbojets. Additionally, his expertise branches into diverse realism, including to the mathematical modeling of membrane reactors, power-to-gas systems, and to innovative development of electrochemical hydrogen compressors. With such a rich and varied portfolio, Professor Can Cholpan stands as a visionary in advancing critical phases of energy and fuel systems. Let's extend a warm welcome as Professor Cholpan joins us on a stage to guide and introduce our next set of insightful talks.
Hocam sunumu gelmiş. Hocam sunumu yok. Dear participants, good morning. Now it's my privilege to invite the first invited speaker, Professor Adnan Midilli from Istanbul Technical University, Institute of Energy. So his presentation title is On Exergy Analysis of Plasma Gasification for Hydrogen Production. So Professor Midilli, the floor is yours. Please welcome.
Ladies and gentlemen, good morning. Dear Chairman, thank you very much for inviting me today. And today I will mention about the exergy analysis of the plasma gasification process for hydrogen production. This is a very new technology for production of the hydrogen gas, hydrogen-rich gas. Actually, this is the project, TÜBİTAK project, subject, and now I will present this topic on behalf of the project team. Meanwhile, I would like to introduce the project team, and I am project manager, and the researchers, as you see here, and we have two consultants. One of them is Professor İbrahim Dinser, another one, Professor Hayati Olgun. We have already completed this project, and we submit the project report to TÜBİTAK. In this regard, I would like to actually, this paper was produced in the scope of our national project. The financial support provided to this project, 117N436 by Turkish Scientific and Technical Research Council, TÜBİTAK, is greatly appreciated for financial support. The content, actually, what I motivation, solid waste management, and conclusion. And meanwhile, I will actually mention about the experimental system of plasma gasification, and also I will explain how can we perform the exergy and energy analysis of the plasma gasification system. And we will talk about some results, and we will discuss what we obtained, and then I will actually share the conclusion with you. Okay, what is the main objective of this presentation? First, we will try to understand the plasma gasification system for waste minimization. This is very new technology, and I will talk about and I will give some details about the processes and the technologies of plasma gasification. And also, when we perform the experimental work, and we will obtain some results, and how can we perform the exergy analysis of the process. And it is really important for the researchers dealing with the gasification technology or pyrolysis technology. As a motivation, actually I will talk about the waste management. What kind of actual wastes we have in daily life? We have actually many wastes. Some of them can be disposed of, some of them actually can be recycled. If you recycle the waste, at that time you can produce some useful products. For example, you have paper as a waste, you can convert into the useful products by recycling. And on the other hand, what we have actually some harmful wastes. We can we have to actually convert these harmful wastes into useful energy or useful fuel. What kind of wastes we have for recyclable actually wastes? As you see here, we have metal. You can recycle it and you can obtain some new products. And also, if you have paper as waste, again you can recycle it and you can obtain some new or some different products. And glass, plastics, organic waste, and batteries, and light bulbs, and electronic waste are recyclable waste, and you can use all these wastes for obtaining the new products for actually daily utilization. On the other hand, what we have unrecyclable wastes. As you see here, in 2020, you know, we had actually COVID-19, and at the end of the COVID-19, we produced many waste, and some of them actually can be called pandemic waste. Pandemic waste are very harmful, and you can use actually plasma gasification technology, which is high temperature gasification technology, and for disposing this pandemic waste. Again, what we have medical waste as well, and you can directly use the plasma gasification technology for reducing the harmful effects of medical waste, or you can directly convert it into the useful energy as well. And you can actually convert the plastics into useful products. However, some of them actually cannot be recycled, and then you have to dispose of them, and you have to convert it into useful energy. Meanwhile, if so, you need plasma gasification technology as well. If you don't use the plasma gasification technology or plasma pyrolysis technology, at that time you cannot actually minimize the harmful effects of the unrecyclable plastic waste. And hazardous waste as well, we have to take into consideration, and we can use all these wastes in the plasma gasification technology. And you know, municipal solid waste are very important for the economy, and you can actually convert these important wastes into useful energy, or you can produce fuels, biofuels, by using this organic waste or municipal solid waste. And also another important source is solid sludge, waste sludge. Sludge is very important for production of energy, and you can convert this into useful fuel as well by using this type of the technology. Here, what I am talking about, actually I am talking about the harmful waste and unrecyclable waste, and you have to develop or you have to consider the actually important technology, and you have to select the technology. When we look at the literature, when we look at the industrial applications, when we look at the actual research products, we cannot see actually any convergent technology except from plasma gasification for this one. Okay, these are important sources for hydrogen production. If so, we have to develop or we have to select the actually the right technology, which is plasma gasification. Here, another important thing is actually dimensions of the plasma gasification. Plasma gasification technology includes actually how these technologies have many dimensions, as you see here. For example, what we have scientific dimension of plasma gasification. You have to design the system, you have to analyze the system, you have to develop a solid model of the system. For example, what you need, actually what we have a health dimension of the plasma gasification. If you produce the medical waste, it means you have to use the plasma gasification for minimizing the effect of the medical waste. And this technology helps actually improve the improve the efficiency performance of the hospitals. And also what we have technological dimensions. Technological dimensions is important. You have to improve the gasification technology. Why? Because a few minutes later you will see the experimental system, and we have to improve the system. We have to actually improve the level of the technology. At that time, we have to take into consideration the technological dimension, as you see here. We have another important dimensions. If you developed, or if you take into consideration the energy technologies, you have to consider all these dimensions for improving the life. Okay, what kind of gasification processes we have? As you see here in the literature, what we have fixed bed gasification. And we can use the fixed bed gasification technology. Actually, the technology is called fixed bed gasifier. And by using the fixed bed gasifier, you can convert the wastes into useful energy as well. Another one, and full-side bed gasification is important. And full-side bed gasification produces the actually very clean gases for the applications. And what we have a train bed gasification process and underground gasification process. And here we have to emphasize, we have to concentrate on the plasma gasification process. By using all these technologies, we can produce the hydrogen-rich gas, syngas as well, and also you can actually separate the hydrogen from the syngas, and then you can use the hydrogen for the applications. Okay, let's look at the plasma gasification system, which is mainly focused on the project. This is the schematic illustration of the plasma gasification process. We have all established all the system in our laboratory. As you see here, we have our plasma reactor, our plasma gasifier. What we need to supply the municipal solid waste for this technology, for this gasifier. And if we don't use the plasma gasification process at that time, we have to actually gasify the wastes between 1,000 degrees Celsius, but it is not enough for the convert the municipal solid waste into useful energy. At that time, we will actually produce many wastes as well, and we have to develop another technologies because of the low temperature gasification process. And then, therefore, we have to add the system arc plasma torch. Arc plasma torch requires the arc plasma power source, and also the plasma power source requires some amount of electricity from the network. Therefore, we have to actually provide the renewable energy. If you have solar energy, if you have actually wind energy, you can use the electricity, green electricity for the plasma power source as well. And if we use actually this municipal solid waste, what we need some gasifying agents. In our study, actually, in our project, we use the vapor and we use some other gasifying agents, and we obtained, this is the schematic illustration of the project, and we produced raw gas, and we clean the gas by using this technology, and then we obtain the clean gas, and also you can use this clean gas for actually in the converging unit for producing for production of those important outputs. Meanwhile, we will obtain the melt at the end of the process. There is no any ash. This is the ash melting, and you can use this melt actually for light concrete manufacturing. Okay. Focusing on this schematic illustration, we developed a solid model of the laboratory. This is the plasma gasification laboratory, which is established in the Recep Tayyip Erdoğan University in Rize, Turkey. And as you see here, we developed the same laboratory. We installed this laboratory, we make this one. And there is no any, how can we say, all equipments are required for the processes, and this area is optimized for the gasification technology. And this is the plasma gasifier system. This is the solid model of the plasma gasification system. As you see here, it includes many subunits. And here you see the plasma gasification system. And these are the subunits, and we provide some cooling, some water, some pressurized air.